So welcome everyone, and thank you for joining us on the second of a three-part webinar series to learn more about the latest AI technologies from both Nvidia and IBM. Today we're going to cover two main topics: the importance of network design for your AI workloads and how to move and protect your data at scale. I'd like to thank our four speakers today: Reggie Reynolds and Scott Schultz from Nvidia, and Dave McDonnell and Chris Mastis from IBM. Nvidia has pioneered accelerated computing, and with its recent acquisition of Mellanox, is now a leader in networking solutions. Reggie will be speaking about why you should consider InfiniBand as the foundation for delivering both performance and resilience for your AI workloads. IBM was the co-inventor of accelerated storage, and together they have decades of experience in building real-world AI solutions that can scale and meet the needs of both today and tomorrow. And IBM has been leveraging InfiniBand for well over 20 years. I refer to NVIDIA's accelerated computing, especially the A100 GPU, as the beast, and IBM's Spectrum Scale Storage as being purpose-built to feed that beast. Our moderator today is Kim Boisson-Shin from R2I. And if you have any questions, please type them in the Q&A section. And at the end of the conference, just raise your hand and you'll be unmuted. And I really encourage you to ask questions. So my name is Tamara Vandersloos. I'm VP of Innovation at R2I. I've worked 29 years at IBM in technical pre-sales, and 70 years ago I left IBM to be one of the three founding members of R2I. Based in Quebec and offices in Toronto and Ottawa, we're now over 40 people and growing. I've had the privilege of doing several service mandates around AI, such as building the AI roadmap, running use case workshops, and had the opportunity to do interviews to institutions around the world concerning their lessons learned and pain points in the operationalization of AI. Reggie Reynolds from Nvidia has over 25 years of experience in data storage industry, working with both enterprise and HPC. Reggie has a leadership role in engineering and global services at Nvidia. Scott Schultz from Nvidia is here to answer any questions. He doesn't show up as with his picture, but he's here to support Reggie and answer a lot of the questions at the Q&A at the end, so I encourage you to ask questions. And he is an HPC technology specialist with a broad knowledge in operating systems, high-speed interconnects, processor technologies. Scott is a 25-year veteran of computing industry and currently maintains his role as Director of Educational Outreach and a founding member of the HPC Advisory Council and various other industry organizations. Dave McDonnell from IBM is the global sales exec for AI, big data, and high-performance computing for IBM Storage. Dave's career is always focused on emerging technologies such as HPC, Linux, and cloud. And before IBM, Dave worked at platform computing and HP for 17 years, always in the area of HPC. Chris Mastis from IBM is an executive architect for IBM file and object storage solutions with over 20 years of experience deploying and designing complex IT systems for clients in various spaces. He has extensive experience scaling performance and availability with a variety of file system technologies. So let's get started. Here's the agenda. I'll talk quickly about R2I and some of the common pain points that I saw in all the interviews I've done with various organizations. Then NVIDIA will speak, then IBM, and we'll talk about the next steps, and we'll cover Q&A at the end. So R2I, the R in R2I stands for resources. We're really a large team of technical resources. Most of our pre-sales people do both service engagements with feet on the ground at clients. The two I's, stand for infrastructure and integration. And integration is really integration into the cloud of your business. It could be in the R2I cloud. We have a very robust cloud environment with 3 different sites and soon to have 4 sites. And specific in the area, although we do support in a lot of ERP, that's really been our foundation on running businesses 24/7. Specific in the artificial intelligence area, we're infrastructure specialists, so we can offer you AI either on-premise in your location, and we will do the service, we will do the installation, the rack and stack, we do service, networking, storage, we do the operating systems and the tools that you might need that we can install for you. We offer it in our cloud as well, or in a hybrid solution, as well as all the services such as building the AI roadmaps or creating an AI lab, our service engagements we've done with our clients. Quickly for the pain points, the ones I've seen predominantly are in two areas. One, in the training times. Customers are looking to improve their training times for their models, and it's becoming more challenging because the number and the size of the data sets are increasing substantially. As AI models are growing in accuracy, they typically also grow in size. So getting them to fit into the GPU memory becomes more of a challenge. And keeping these GPUs at high utilization rates is another challenge I've seen. The GPUs themselves are a large investment in the cluster, and you really want to get those ones going, fully utilizing them. And that's where the IBM storage comes in, because you want to feed that beast. The data pipeline is really where we see most of the customers spending 80% of their time. It's not actually on the data science. It's about finding that data on the many siloed data sets. It's ensuring the quality of the data and that the data sets are properly labeled for ingestion in the models. And also your ability to move that data where you need it in a timely fashion. So now we'll go right on to Reggie, who's going to be talking about InfiniBand for NVIDIA. It's on to you, Reggie.
All right, hello everyone, and thank you to Tamara and the entire RTI team for hosting this event and inviting me to share. So just like with all areas of technology, storage has advanced rapidly in the last decade to keep pace with the explosion of data in the enterprise and AI and HPC. We'll touch on how NVIDIA is addressing these challenges in these areas from a networking infrastructure perspective. And you will hear from Dave and Chris on how IBM is utilizing NVIDIA technology such as InfiniBand and GPUDirect storage to accelerate their storage solutions. Our objective is twofold: to provide a fundamental understanding of InfiniBand technology along with covering the NVIDIA InfiniBand product line. In addition, we want to convey that it's the ideal solution for avoiding performance, security, and scaling pitfalls associated with trying to use standard networks at scale for compute and storage interconnects. 10 years ago, scientific computing primarily consisted of first principles simulations and basic visualizations in a centralized computing facility. Today, researchers are fusing traditional simulations with deep learning, big data analytics, and streaming edge computing to solve the mysteries of the world. It is the newest trend of what I refer to as data-driven scientific computing. Higher fidelity sensors and the ability to run large simulations have resulted in an exponential increase in the scientific data that needs to be processed for insights and can require data analysis and processing to occur at the edge. These demanding workloads rely heavily on smart, robust, and secured networking from the edge to the larger supercomputers and various appliances. Additionally, enterprise data center architects have seen a flurry of innovative new technologies, practices, and usages driven by both software and hardware advancements, which have delivered a multitude of benefits to the businesses, but also introduced new challenges. For example, virtualization has enabled significant consolidation of workloads, but has dramatically increased the data communications traffic, creating bottlenecks for I/O access. Another example is the software-defined data centers and private clouds have turned data centers and IT shops into valuable service delivery engines with self-service portals, but the networks and storage must now keep up with more flexible data center architectures. And lastly, Flash, NVMe, and NVMe over fabric-based all flash array storage solutions deliver much faster performance, exposing bandwidth bottlenecks and high latency sensitivities in traditional network connections. Also, now in the era of accelerated computing, instead of a CPU-based server, the entire data center is the new unit of computing. And to make this model work requires GPU for accelerated computing and the data processing unit, or DPU, for accelerated data processing. The CPU is still part of this triad of computing. However, with GPUs and DPUs, the CPU is free to perform application processing, which it's good at, while the GPU performs massively parallel processing, and the DPU performs data-intensive functions like security, communications, and data I/O processing, compression, and encryption. The new architecture is the future of computing and depends fundamentally on the GPU and the DPU building blocks to make the data center scalable and efficient.
Do you mind pushing the hide button on Reggie on your slide so we don't see?
Yes, I can do that. There we go.
Perfect, thanks.
Okay. Now, NVIDIA has invested and believes that in InfiniBand as it being the network of choice for data-intensive scientific simulation and data analytic application. InfiniBand remains the most efficient way to move data using the fundamental concepts of RDMA to do direct data placement into the user space, having no need for CPU or operating systems involvement, therefore delivering the highest performance and return on investment at any scale. By bringing additional network engines and capabilities closer to memory and offloading more tasks from the compute and onto the network, we now have a smarter, more capable, and most efficient network solution that can participate in the application runtime. InfiniBand is the optimal and ultimate software-defined network with complete centralized management. It is also an open standards-based technology that has been accepted by the high-performance storage community because of its previous and future generation compatibility. InfiniBand architecture defines an infrastructure which not only has superior performance and latency, but provides better data center security in standard high-performance networks. The InfiniBand architecture provides robust in-network security mechanisms that are not capable with other standard networking solutions. Currently, NVIDIA is delivering HDR 200 gigabits per second InfiniBand networking products and solutions, with NDR coming early next year, NDR 400 gigabits per second. The ConnectX Smart NICs InfiniBand adapters are RDMA optimized and support in-network computing plus storage, cloud, and security offloads. The Bluefield Data Processing Unit provides high-performance programmable network engines coupled with ARM CPUs to enable customization and optimization of both control and data path operations. Along with the DPU, there is an NVIDIA Data Infrastructure on a Chip architecture, better known as DOCA, software development kit that enables developers to easily create high-performance software-defined accelerated services leveraging industry standard APIs for storage. Then we have the Quantum InfiniBand switches that deliver a complete chassis and fabric management solution to build cost-effective and scalable switch fabrics, ranging from small clusters up to thousands of nodes, reducing operational costs and infrastructure complexity. Advanced features such as adaptive routing, congestion control, and enhancement quality of servers ensure the maximum fabric performance under all types of traffic conditions. And lastly, we have the LinkX cables that provide an industry-low bit error rate, lower latency, and lower power for superior connectivity. To complete the family of InfiniBand products, we start with the Metro-X long-haul InfiniBand switch that can connect your InfiniBand storage solution to data centers up to 40 kilometers apart. Second, we have the NVIDIA Skyway Gateway appliance, which offers a scalable and effective path to seamlessly connect InfiniBand and Ethernet infrastructures while maintaining the lowest InfiniBand latency within the data center.
So Reggie, that's the appliance that customers would use, that if they're all Ethernet and they want to start to transition towards InfiniBand?
Yes, or if they want to keep their investment in Ethernet and then add InfiniBand fabric or InfiniBand infrastructure, they can do that as well.
And that's the appliance they would use for that?
Yes, that would be the appliance. And some, and there's some data centers or some places where we go into that already have a significant Ethernet investment, but they want to accelerate their I/O within InfiniBand, and they can do that without throwing that investment away.
All right, thanks.
Yep. Now we also have the unified Fabric Manager Cyber AI appliance that provides complete management and monitoring functions for your entire InfiniBand network infrastructure. Some of the features include network configuration, testing, and secure cable management. Also, network telemetry and traffic monitoring, along with congestion discovery. In addition to that, performance, health, and fault monitoring that detects performance degradations, anomalies, and usage changes, and provides customizable alerts to the IT administrator. These are just a few of the features that UFM provides for enterprise-level management of your InfiniBand infrastructure. Now, touched on it earlier, but the NDR will be releasing early next year. This next generation architecture will include an entire NDR end-to-end solution, starting with the ConnectX adapter. The adapter will support PCIe Gen 5 and will have advanced programmable data path and in-network computing capabilities. The Bluefield 3 DPU, in addition to the capabilities of the ConnectX 7, will have faster ARM cores and support DDR5. The Quantum 2 switch expands the port count by 60% from 40 to 64 NDR 400 gigabit per second ports, or you can have the option of 128 200 gig NDR 200 ports as well. And then we will have a modular switch that will support 2048 400 gigabit per second ports, or 4096 200 gig per second NDR 200 ports. And of course, the cables and transceivers are updated to support these higher speeds. Within NDR, we bring the next generation, which continues to set world records, and enables this next generation of AI applications and storage solutions by increasing the bandwidth with twice the throughput of HDR, four times faster message passing interface, what we call MPI performance, improved total cost of ownership with five times the switch capacity, and 6.5 times scalability, making NDR exascale ready. Also, the 32 times AI acceleration with updated in-network and computing technology. So I want to take a brief moment to talk about an exciting new software product that's part of the Bluefield DPU that I mentioned earlier. The product is called the NVMe Software Defined Network Acceleration Processing, or better known as SNAP. SNAP is delivered as part of the Nvidia Bluefield DPU software library, better known as DOCA, that I spoke of earlier. It allows storage solution providers and customers to compose remote server-attached NVMe flash storage and provide access to it as if it were local. It makes use of existing NVMe interfaces to give users the composability and flexibility of network flash storage, combined with the advantages of local SSD performance, management, and software transparencies. The ARM processors in combination with SNAP can be used to accelerate distributed file systems, compression, and data protection and validation such as T10-DIF and many other storage applications. We're excited to collaborate with IBM and their engineering team to explore enabling their products such as Spectrum Scale on the Bluefield DPUs to produce solutions that can further accelerate your AI data centers and increase security. AI data sets continue to increase in size, and the time spent loading data for a given application begins to place a strain on the total application's performance. When considering end-to-end application performance, fast GPUs have become increasingly starved by slow I/O. The process of loading data from storage to GPUs for processing has historically been controlled by the CPU. Nvidia has addressed this issue with GPUDirect storage, or what we call better known as GDS. GPUDirect storage enables a direct data path between local and remote storage like NVMe or NVMe over Fabric and GPU memory. GPUDirect storage avoids extra copies through a bounce buffer in the CPU's memory, enables a direct memory access engine near the NIC or storage to move data on a direct data path into or out of GPU memory, all without burdening the CPU or GPU. Dave and Chris will go deeper into their implementation of GDS and provide performance information as well. Now, Nvidia has worked with Dave, Chris, and their IBM team to provide a reference architecture that includes IBM storage along with Nvidia DGX A100 systems. This enables the quick and simple deployment of a validated solution with shared extensible storage that is designed to keep for deep learning, inference, data exploration, and other I/O-intensive workloads. This is huge as it provides a solutions architecture along with solutions configuration parameters to optimize the interactions of the essential components of the solution, to include IBM Spectrum Scale, IBM Elastic Storage System 3000, known as the ESS 3000, Nvidia InfiniBand quantum switches in combination with either 2, 4, or 8 node Nvidia DGX A100 systems. Having a reference architecture facilitates the deployment and configuration of Nvidia DGX A100 systems using IBM Spectrum Scale and the IBM ESS 3000. So in summary, InfiniBand's ability to offload tasks and provide in-network computing capabilities optimizes the performance of storage solutions such as IBM Spectrum Scale and ESS 3000. InfiniBand delivers superior performance and lowest latency while also providing enhanced quality of service, security, congestion control, and adaptive routing.
Okay, so hi everyone, I'm Dave McAnell, and I'm joined by my colleague Chris Maestas. And we're going to build off some of what you heard from the NVIDIA side, from the excellent presentation, and talk about how this comes together. We'll also share what some of the challenges are. So by now, everyone here, I'm sure, realizes these NVIDIA GPUs are just incredible. They're incredibly fast, and they're expensive, right? They're a precious resource. You want to make very, very good use of them. If you're not feeding them properly, you spent a lot of money to not take good advantage of it. So we partner at all levels of NVIDIA and have for many years to help optimize this. By the way, we go back, we love the Mellanox side of NVIDIA. We are their oldest partner. We've always been one of their largest OEMs and support providers, more than 20 years, by the way. So we have some experience in this space, and they've always been our preferred and recommended partner for networking architectures when performance and resilience matters. By the way, if I was thinking how I would answer the question you asked, Tamara, I would have said the same thing that Reggie said. It's about performance and resilience. They're purpose-built for these types of workloads, which in the past were more high-performance computing-centric, but now that the GPUs have become so powerful, and NVIDIA's done such a good job on the software side of making it more consumable, it's not just high-performance computing. And we've got a whole analytics and AI sector opening up because it's now so much more accessible. So I'm going to articulate a vision. If you know anything about IBM, you know we're about artificial intelligence and hybrid cloud. So what does that actually mean to any prospective customers of ours? It means being able to run at extreme scale, complete edge-to-cloud view. It means being able to do this securely, anywhere. It means having enterprise-grade capabilities absolutely everywhere, and accessible by anyone, whether it's your customers, your partners, your employees. So, or put simply, anyone from anywhere with anything, right? Be it a phone, tablet, laptop, sensor, camera, whatever. So it's a fairly simple vision to articulate. It's incredibly difficult to deliver. So we have been working on a purpose-built parallel file system for 30 years. It started in government and extreme capability computing workloads, but it very quickly got adopted, and the roadmap was driven by large, globally disparate companies. So we've been working on lots of technologies for data sharing globally, for security, for things like tiering, and too many things here to list, but basically not only the extreme performance capability, but things like security, optimization, for cost protection, and access capabilities. And in today's vernacular, we would say deploy in the edge, deploy in your data center, deploy in public cloud. Write once, deploy anywhere. You don't need to re-architect an application for any of these. You write it once, you deploy it anywhere, and you get all this enterprise-grade capability. So most customers don't tell us that they struggle with storage. They know how to buy storage. They've been doing it for decades. Where they struggle is at the workflow level. So we try to look at this at a workflow level. We do this in partnership with Nvidia and with our partners. And we try to help customers look at this from the capture points. And by the way, this is a big bottleneck in the world of 5G, AI, IoT, or high-density cameras, or even with video going from HD to 4K to 8K or whatever. These are very hard problems. There's very, very big growth in streaming applications. Think Apache Kafka. So we see customers that either have ingest bottlenecks today, or if they don't, they know they will. So they're planning for this and trying to lay down an information architecture that can scale. We see lots of challenges in organizing the data, categorizing it, labeling it, making sure they can work with it efficiently, sending only what they need to those precious GPUs, and also ensuring that they can find it 5, 10, and 20 years from now to be able to work with it effectively as they enhance their model, sometimes daily. And then, of course, there's the analyze process where you're training and building your model, testing it out, making sure that it's ready. And then, of course, the actual machine learning or inference capabilities. So we have technologies that help through this entire workflow. We've done reference architectures or blueprints with NVIDIA to help look at this at an entire workflow level. And that's where we're trying to become a trusted advisor to customers to help them on this journey. So you'll see here examples where we bring data in at high speed. We work on tagging it, and then you need very high-speed storage, usually something like NVMe flash-based storage, to actually run through the training of your model and the actual machine learning or inference portion of it. But when you're not working in that high-performance phase, we'll try to tier that off to a lower-cost accessible tier. So that could be object storage, it could be somewhere in the cloud, it could be tape, just as examples. So it's a software-defined approach. We also, as a best practice, try to help customers get onto a roadmap where they can collapse silos and design for multiple workloads at the same time. Customers use multiple analytics tools. Most AI has started with analytics somewhere. And so you have all these different silos of data. A lot of times it's the same data replicated to feed multiple different analytics tools at the same time. We see this also happening in AI and with machine learning teams. So we're trying to help customers get onto a path where, yes, start very small, start very quickly, start with something very simple to deploy to support a data scientist who doesn't have time to spend a lot of time thinking about this, but make it so that if you buy storage systems 2 through 10 or 11 through 20 or whatever, that you have something that can scale and fit into something that's bigger, simpler, efficient, and easy to manage. So all kinds of different workloads use this kind of data that machine learning practitioners need to access. It comes from a lot of different sources. So we're trying to help customers share and take better advantage of it. So we talked in the title here about avoiding pitfalls and common pain points. There are all kinds of them. The feed the beast phrase that Tamara started with is a very common one, and it's what we ran into with Continental Automotive. They didn't have a problem, putting a single NVMe device attached to a single DGX server. That part's easy. Well, how do you serve a whole group of data scientists who have access to 50 DGX servers, right? That becomes a throughput problem. So we have spent decades working on tuning, rewriting parts of, and building for environments like that. So that's something that ultimately customers need, something that can scale and become efficient as this becomes more scalable. So data duplication is a very common problem. We see customers starting on a laptop, maybe doing a POC with GPUs, going to GPU workstations, going to servers. The storage corollary to that is usually buying, maybe starting with the USB drive or starting with the storage system number 1, say. When you buy storage system number 2, what do? You copy all that data onto storage system 2. Well, what happens when you buy storage system number 3? You know, and so on and so on. It's if you don't have an information architecture that scales, you're making multiple copies of the data, so you get multiple versions of the truth. Couldn't possibly be more expensive, couldn't possibly be harder to manage, couldn't possibly be harder to scale. Now, I'm not going to spend as much time on each of these, but we see customers running into challenges with high-speed backups and archiving. Most customers don't have a process they trust that can get them through the next 3 to 5 years. So we help with this area. As AI gets into production, we have customers that actually need to have fault tolerance and disaster recovery built into production applications. So that's a requirement that we're getting into a lot of conversations with. Security gets a lot of attention these days, but it's not just security, it's also regulatory requirements for things like multi-site backup and disaster recovery. These are conversations we didn't always have in the world of high-performance computing that, you know, we do have when someone wants to take AI and take it from the level of developing and enhancing a model to, you know, putting it into actual production. Of course, customers need easy ways to grow. They need to interoperate with existing applications and technology that they own, and they need to be able to do this globally, and also deal with ingest problems. In the telco space, as an example, we have you know, customers telling us they're going to need to be able to do analysis of 1 billion data points per second. Well, that's a pretty big ingest problem amongst many that are out there. The pain points also get articulated differently depending on role types, and I think this is a really, really helpful view. We share this with our sellers a lot to help educate them on how to serve our customers well. So in DevOps, you want self-service, rapid access to storage. If something goes wrong, you really need to be able to recover. You need a solid data recovery plan. And as we mentioned earlier, write once, deploy anywhere. So we see huge interest and faster interest than we expected in the move towards containerization of applications. Likewise, from a data scientist, the data scientists, they spend a lot of time. Tamara had a stat that has been replicated many times as different analysts have done reports on it. 80% of their time is spent dealing with data issues, finding data, tracking data. So being able to tag data and tag it in a scalable way, that's something we do. That's something that speaks well to challenges they have. We also hear the problem articulated as challenges in sharing data. And so these are, you know, common pain points. And of course, being able to take advantage of those expensive GPUs, just feeding them and keeping them busy. There's usually there's a gap between any group of data scientists and IT operations. There's some almost natural tension built in because the data scientists always say IT doesn't understand the business. They're probably correct when they say it, of course. And then IT will say, hey, you know, data scientists, you don't understand about, you know, things like network security and governance. And guess what? They would also be correct when they say that. So on the IT side, they're looking for governance, simplicity of management, automation, and consistency, and making sure they have an appropriate data protection strategy in place. So I'm going to pass this over now.
Dave, I'll just add one part, and you, Mark, I see on the slide here, quick data discovery. One of the pain points I see is that the customers have a tremendous amount of siloed data, and they don't even know where the data is and how much data they have. Just the inventory of their data is difficult.
Well, that's why we built Spectrum Discover. It's one of the less known parts of our portfolio, but this engine that we've taken for Spectrum Scale, we've actually put it into Spectrum Discover so they can tag with high performance, tag with something that scales. We have customers using Apache Atlas. It's great, but it doesn't necessarily give them the performance they always need, because just being able to answer simple questions like, what do I have? Where did it come from? Who created it? When did they create it? Is actually very difficult for customers to answer. And they know they're going to deal with 1 or 2 orders of magnitude of larger data sets today or over the next year than they have over the past decade. So you've got to have a way to be able to label and track data. And of course, we're doing this at an infrastructure level. We integrate to things like the IBM Watson Knowledge Catalog or other tools that help customers do this.
Yeah, thanks.
So Chris, I want to take this from more what we're seeing on trends and best practice sharing to some of the more tangible real world stuff. So Chris Maestas Architects works with customers every day doing this. So he's a great person for us to listen to and get advice from. Chris.
Sure. Thanks, Dave. So thank you, Dave, for the great kind of talk. And like I said, what we've been sort of doing here at IBM and working with NVIDIA hand in hand in terms of GPUDirect storage, in terms of InfiniBand technology, right? NDR kind of testing that we're sort of doing, all of that stuff. So we're doing that now. And we're excited to share with you some of the results we've been working on, right? There's been a technology preview of what we call GPUDirect storage, having the GPU directly write, bypass the CPU and write over an InfiniBand network to a Spectrum Scale installation. And here we basically have, again, results of 2 of our elastic storage systems. These are flash-based, systems running Spectrum Scale, running erasure coding, data protection, all of the things that Dave has been talking about, connecting to a couple of DGX A100s, right? So in theory, right, we have a number of links, right, that are connected from each of the units, right? So about eight links, right, within the 2 units. And in theory, you have 400 gigabytes a second of theoretical performance. The connections to our storage itself, right? We have 8 connections, so it's at roughly half of that, and that's what you sort of see here on the screen, right? 4 here and 4 there. So, that's what we should be seeing in theory, right? And what we always want to do is whenever you get the best bang for your buck, right, we ask about why is InfiniBand better than Ethernet? This is really why, right? From a storage perspective here, doing with IBM, we want to get the theoretical for you in reality. And you can see in our results today, right, 191 gigabytes a second. So that 200 gigabytes a second of theoretical performance, we're 9 gigabytes shy, right? And here at IBM, what we do a lot in our research center, in our development team, when we work in the field with our performance testing, right, we try to incrementally get to that theoretical level of performance. We've done this with InfiniBand technologies like EDR, that it was 100 gigabyte, 100 gigabit type of networks, right? And now we're able sort of to do that as well. So you can sort of see here, right, it's kind of showing you the connectivity that's sort of working here. This is Spectrum Scale, our latest release of Spectrum Scale. This is 2 NVIDIA DGX A100s and some ESS, elastic storage systems, which are flash-based running 3200. We're really trying to optimize from the analytics environment to the storage, right? Get out of your way. And in Dave's chart earlier, where he talked about the analytics, the machine learning, the ML/DL kind of learning phases that are occurring, that's what that phase is about. If we go to the next slide, we can sort of see here, Dave, essentially on the next slide, what this is sort of about, right? We have ingesting the data, right? We're actually doing the analytics of it. Whether, again, it could be some DGX environments. We can be tiering the data from this 3200 device that we have running on an InfiniBand network, right? That's HDR 200 right now, and have that data tier over to slower disk, like sort of Dave was sort of saying. It's still actually pretty high performance disk, right? These particular units are doing over 80 gigabytes a second of read performance, these flash units here. But our spinning disk models, they're not so bad themselves. They can do about 55 gigabytes a second of performance, right, for spinning disk. So again, here at IBM, we always focus on the maximum performance of, the storage, right? What are we doing with Spectrum Scale? So we can tier the data. We can present that data out to other analytic environments. So say you've done, something here with the NVIDIA GPUs on the InfiniBand network, and now you want to do some other type of analytics on it. Maybe it's SAS Grid, maybe it's Cloudera, right? We have a way to present the data, you know, via HDFS, and you can access that without having to make multiple copies of the data. You keep it fast, high performing in this environment, and then we can back it up, we can push it to tape, we can share it to other object storage as well, right? So this is kind of what we've done here at IBM and expanded kind of the footprint of not just that high performance, which is again what we do with Spectrum Scale. That's, you know, job number one: performance, scalability, security, right? But giving you that data lake view, or now sort of the new term, right, is the lake house kind of view of what you're actually doing. If we go to the next slide, we can kind of see a little bit here on, you know, the terminology, you know, of, you know, this ingest flow, you know, bringing in data in, right? And how am I doing that? Maybe at Spectrum Scale running at, you know, on a device, right? You know, maybe you're sort of bringing in autonomous driving, video collection, right? And you're sending that from an edge device into Spectrum Scale, or you're sending it to a cloud object, you know, storage environment, right? So these are kind of some of a mapping of the products we have here at IBM to kind of these phases and what's going on. So ingesting, we can sort of be reading from various environments as we do the cataloging of the data, right? And here in this example, right, we have some pictures of roads to try to identify potholes, and we can sort of have that, you know, the various kinds of image is cataloged. You know, we can use tools like IBM Visual Insights, Visual Inspector to look at these images, right? And, you know, we can automate kind of processing the image. Does it have a stop sign? Does it have a pothole? And then integrate that with Spectrum Discover to automatically tag that image. So now we've done the ingest, we've done the data preparation, we're going to curate it a little bit more, right? You know, and sort of say, well, you know, what is this, you know, what was the camera? Was it the front camera, the rear camera? You know, was it a sensor on the side, right? Sort of seeing that in the curation kind of phase. So still using Discover. And again, because this instance is in Spectrum Scale, you're basically able to access the data, again, without having to copy it. It's like, well, okay, I'm going to look at the data, it's here, I'm going to do an additional tag to it, and it's one and done, right? The fidelity of the data is here. I'm not making 2 or 3 copies, and I don't know if there's a copy in ingest and a copy in data mapping, and a copy in curation, and a copy in training. So I'm not having 4 copies, 1 copy, just doing the data flow changes here. So Spectrum Discovery is helping us to, again, look at, you know, the auto tagging the features of the environment, look at the curation of this data environment. And now I'm going to do some training, right? I'm going to actually run this with an Nvidia DGX A100, right? I'm going to actually, you know, have that run to Spectrum Scale with maybe with an ESS 3200, right? So that's actually going to be able to be run there, do the training, and then, like I said, at the end of the day, because of compliance reasons, because of other kind of requirements that I have, I need to keep the data around. So I'm going to maybe store that data in a high capacity storage environment. They could be, again, Spectrum Scale still. It could be a tape environment, or it could be, again, a cloud. We can store that to an external cloud. So this is kind of, again, a view of the storage for AI workflows and that mapping. If we kind of see in the next slide, we can sort of talk about, you know, again, these various phases, right? The differentiator we really have here. When you need the speed, the performance of what's going on in the training model, right? We have that. That's the Elastic Storage System 3000, 3200 environment that's there, right? So we can ingest data, whether it's from the edge, we can actually do the training on that very, very fast. And then when we're done with the data, right, or we want to sort of do some other analytics on the data, maybe, again, Cloudera, maybe some other ISV application that's out there, we can do that computing on high capacity tiers. So we can maybe push some data out to an object store and sort of do some more calculations, pull it back in. We can have that data get presented to another Spectrum Scale Elastic Storage System that's spinning disk and sort of have that kind of presented as well, or we can actually have that go to a cloud. So these various layers of performance, of high capacity, and then finally, the need of actually storing the data for a longer term, right? Having that accessible archive capacity where, you know, you want to grab something from the object storage, cloud object storage, right? Or you want to grab something from a tape, right? And start to read some of the data, you know, that's on tape, and getting access to that very fast. We have that differentiation, right? Again, performance is there, scalability is there, but the lifecycle management and the optimization of what to do with your data when you're done with it, that's what we bring in that value add here. And I think if we go to our next slide, Dave, go ahead.
Chris, I have a lot of customers talk to me about the need for a single namespace. If you go back to that previous slide, where is your single namespace?
That's it. We can, with software, we can take everything shown there. So let's get specific. Let's say we have 3 ESS 3200s. We have, say that's I don't know, a petabyte, and then we have 10 petabytes at the middle level there. And let's say we have I don't know, 10 different chassis of ESS 5000, and then we have 2 tape libraries and 2 object storage. With Spectrum Scale software, to the user, that looks like a thumb drive or a D drive, right? So that's the power of making this simple. And then we have policies that will automatically move it from one tier to another. And of course, those policies are flexible. Some of it could be based on I'll say storage attributes, date the file created, file size, date last access. With Spectrum Discover, it can be with business specific. Let's push down everything except the stop sign and pothole tag data to a lower tier, because we know in the next month our focus is really going to be on stop signs and potholes as an example. So that's it. That whole thing you're looking at, that's a D drive.
Yeah, so the whole triangle is really the single namespace as far as the user is concerned.
Yeah, exactly.
Nice.
All right. So,
okay.
I think, Dave, I think we're gonna. Yeah, go ahead.
Sorry, Chris.
No, you're fine, Dave. Go ahead. Sorry.
Okay, so specifically with NVIDIA, we have done a lot of work to make this reality for AI practitioners. We do them, of course, mainly with the building blocks NVIDIA owns, which are the DGX servers and the NVIDIA Mellanox InfiniBand networking. Though, of course, we have customers that access this from other suppliers and users of A100s. But with NVIDIA, we have a partner network like R2I that helps customers put these all together. So we have reference architectures showing scalable performance with one of our most recent ones was with 2, 4, and 8 pod configurations of DGX servers. We've done SuperPod work with NVIDIA. We've done what we call our AI workflow blueprint, where we use Spectrum LSF to trigger jobs that went into IBM Cloud Object Storage, then tagged with Spectrum Discover, and then, of course, Spectrum Scale for inference and training before returning the data back into Cloud Object Storage. That's a full workflow, just like we've been talking. That's a paper that exists. We've done AI with Red Hat OpenShift containers. And that was a collaboration with NVIDIA out in Europe, where the feedback from NVIDIA and the account team working with a specific customer there told us they would have saved 9 months of effort if they had that paper sooner, right? So not everyone has experience doing AI with Red Hat OpenShift containers and putting containers into production. So these are some of the things that we're doing to try to make it simpler, easier to consume, and get customers focused on their business instead of getting slowed down by technology hurdles. And then some of our most recent work over the past year, and this has been not only on the GDS side, but also with our friends from the Mellanox side to make sure that we can do this at a system level. And many systems have more than one network. Just an example of the type of collaborations going on. I already alluded to the fact earlier that we've liked Mellanox for more than 20 years and been working with them, but we really like NVIDIA because they're innovators. And IBM's an innovation company. We have a lot of synergies and culture. And when we go into joint collaborations, we get in pretty deep with them to make sure that they can scale. So these are the types of things we're working on with NVIDIA. We're both heavily reliant on partners. So R2I, we're grateful to you for helping pull this together, but partners are where we help make this work, where these reference architectures become relevant. And we know that customers increasingly rely on them because there's a lot coming at our poor customers with containers and AI and the AI frameworks and so on and so forth. So we hope that this combination will be helpful for customers to make it easier so that they can focus on the task at hand and make technology something that is just simple, easy, and works. And I think, Tamara, this is the point where we should pause and see what other questions might have come in.
As you know, this is the second of a 3-webinar series. So the first one was really more at talking about use cases, more targeted at the executives. This one was more on the technical side, targeted towards those that are running the clusters. And so I encourage you to share the other webinars. We've recorded them so you can listen to them after the fact. And register for the next one. The next one is really targeted at the data scientists themselves. And if you want to reach out to us, as David mentioned, we can do a personalized session on any one of the subjects that you might have seen, because we've covered a lot of material today. But if anything interests you in detail, we can go in a personalized session on any of the subjects. We can do a use case presentation that's specific to your industry, or a use case workshop. We've done quite a few of those with customers, helping them identify which AI use cases would be a good one to start with. And then we do service engagements around building the AI roadmap or setting up an AI lab.
I'm going to give a little quick plug for your webinar that you have tomorrow. Our presenter will be one of our most senior architects, Piyush Chaudhary, who we call PC. He'll be talking and referencing some work that we've done internally. We've got a demo as a part of it. The biggest and most surprised users of that have been some of our internal data scientist teams and internal IBM research teams. Or in the words of our CEO, Arvind Krishna, this has been one of the most exciting things he's seen from the IBM storage team in 10 years. And so you'll be able to see something that actually not a lot of people, even inside of IBM, have had the chance to see yet. So something that we can show demonstration of an AI type of environment in a hybrid cloud world. So hopefully you can make it.
Perfect, thanks. And I also had a question, and I don't know if this is to Chris or to Dave, but the ESS 3200 just came out in April. What's the difference between the 3200 and the ESS 3000 that everyone knows and loves?
PCI 4 and double the performance. So we were getting around 40 gigs per second and 2U in the previous ESS 3000. We're getting, well, in fact, you saw the numbers. We got 191 between two, which is 95.5 gigabytes per second. Most customers don't believe that's possible. They want to see the data and so forth, but to get that in a tiny little 2U form factor is pretty shocking. Chris, did I miss anything?
So it's really PCIe 4 and double the performance.
Yeah.
Okay. Which is huge. It's not a small feat. Are there other questions? For the GPUDirect, and maybe this is a question for Reggie, what kind of improvements are you seeing? And I know it really depends on the workload, but what kind of performance can customers expect for some complex models when leveraging GPUDirect? What have you seen?
And that's a great question. In some cases, as much as 2 or 3x per improvement in performance. And probably, I don't know if Chris might have some numbers as well, because there's some, you guys can actually give a true a true measure of what you guys have experienced, Dave and Chris. Is there any comparisons that you guys have seen as well with your testing?
Chris, do you want to take that one? Oh, we might have lost Chris on audio. So Chris, if you're not here, I will take this. So we are working with the team very closely. We think that's part of how we got that 190 gigabytes per second, right? So instead of 40 gigs, we got up to 95.5 gigs per second. So we've seen a boost on that. We think the key to the GBS adoption, which we expect to go into, from beta into production fairly soon, is that we need to be very clear on, which parts of customer workloads it's going to accelerate, right? It's and it also requires some work with the applications team. So we're pretty excited about getting that out, and we are working with some customers right now to, set up, POCs for them. So we'll have a lot more data on this in another couple months.
Yeah, it's a brand new technology, so. That's exciting. Thank you. So we've come to our noon, which is when we said we'd finish the presentation. So please share this link with this one if you think others in your team might be interested in it. And I'd like to thank everyone for their time, and I'd really like to thank the 4 speakers for the investment and time that you've spent on this. So thank you, everyone.
Thank you.
Thanks, Jamar. Take
Thank
care.
you.
Bye-bye.
Thanks. Bye.
Au revoir.